A second example of electrochemistry application is the process of electrolysis and electroplating. If enough electricity is applied to a redox reaction, you can get it to occur in the backwards direction, or the non-spontaneous direction. Electrolysis is the technique used to decompose compounds into their elements using electricity. Here's an example. Chlorine gas is a very highly valued industrial chemical. It can be created by taking sodium chloride and decomposing it using electrical means. Here, molten or liquid sodium chloride is fed into a big kettle. Then electricity is fed through. The cathode supplies electrons to the Na1+ in the NaCl compound and changes it into elemental sodium. Whereas electrons are taken from the chlorine ions and make chlorine gas, which bubbles out of the liquid and is captured in a container. Electroplating works also by running a redox reaction backwards. Here we have a diagram describing how copper can be refined into a pure sample using electricity. An impure copper sample that comes from a mine is placed in a copper sulfate solution. If electricity is run through this system where we have a pure copper anode, we will get oxidation at the cathode. That creates more Cu2+ ions. Those can travel across in the container and be reduced into copper solid onto the pure copper rod. Electroplating is also used for a number of other applications. It creates a thin layer of a pure metal over top of another metal. It is used in plating jewelry, in corrosion protection, and in metal purification, like the example we just discussed. Since we build and construct a lot of items out of metal, corrosion protection is a big deal for humans. We spend a lot of time and money trying to prevent our metal things from rusting. Rust is a spontaneous redox reaction involving an exposed metal, water, and oxygen. To prevent rusting, you can do it by a couple of different ways. One is by creating a physical barrier between the metal and the oxygen. We can either paint or oil metal structures. We can also use redox reactions. This technique is known as cathodic protection. We attach a block of more reactive metal to the metal that we would like to protect. For example, in this picture, we're trying to protect this iron boat from rusting in seawater. Notice at the bottom there are blocks bolted onto the ship. These are made out of pure magnesium or zinc or aluminum. These blocks of more reactive metals are known as sacrificial anodes. They will oxidize first, leaving the metal we want to protect unreacted. When the sacrificial anode oxidizes, it feeds electrons to the metal we want protected, therefore making it a cathode. Another method is galvanization, and it usually involves coating iron with a thin coat of zinc. Galvanization provides both physical and redox protection to the iron. It provides a physical barrier between the oxygen and the iron you don't want to rust, but also the zinc is more reactive. So when it rusts first, it supplies the iron that we want protected with electrons so it cannot oxidize itself. therefore providing cathodic protection. Check out the animations on galvanization, which is how it's done industrially, and then also the video on cathodic protection.